Okay, I'm back, and so now we want to learn, where does groundwater reside? Well, it's going to reside in the ground, but we want to be a little bit more precise about that. So there's a couple of words I want you to know, and so the first one is called porosity, which is the amount of open space in a material. And there are two kinds of porosity. So you have primary porosity and then secondary porosity. So primary porosity is going to be open space in a sediment after deposition or a rock after lithification. So let's look at gravel, for example. So here is some pieces of gravel, and then you notice there's some open spaces right in here where water can live. Okay. On the other hand, secondary porosity is going to be after you have a rock. So now let's say that it's limestone. Okay, so this is our symbol for limestone. And let's say that it is completely solid. How porous would it be? Well, not very. But now let's say that there is an earthquake or something that causes a crack to appear in it, or maybe it's the limestone is dissolving away, so that there is, again, some kind of a crack or crevice in it. That can fill up with water, and then that would be referred to as secondary porosity. Okay, then you have permeability. So permeability is going to be the ease at which water can flow through a material. So this particular material right here is going to have a high permeability because you can see that the water is able to travel through it. Gravel is going to be an excellent permeable material. It allows water to go through it. So let's make up a chart then, and we're going to put permeability at the top. And then that's going to go from low to high. And then over here, we're going to have porosity, and it's going to go from low to high. All right, so now we've got 4 blanks that we need to fill in. So what kind of a material would have a high permeability and it would have a high porosity? Okay, so we've already just discussed that, and so that would be like gravel. So gravel would be an example of a material that it has the capability of holding a lot of water, and it also has the capability of transmitting a lot of water. Okay, so what would be an example then of something that has a high porosity, but it has a low permeability? So it can hold a lot of water, but it doesn't allow water to flow through it. So an example of this is going to be clay. So if you've ever taken a piece of clay and you stuff it into a glass and then you pour water on it, you'll notice that that clay will begin to swell. So in between the little flakes of clay, water can live. So that clay has the ability to have a very, very high porosity. But on the other hand, it doesn't allow water to flow through it. So again, those clay minerals, they're going to stick together. And so they're going to not allow water to flow through it. So for example, farmers will put clay barriers at the bottom of their ponds. And that will hold the pond water in there because the water cannot flow through the clay. All right, so that fills up these two. So what would be an example of something that is going to have a low porosity and then it would have a low permeability? So it's something that cannot hold a lot of water and it doesn't allow water to go through it very easily. Well, that would be like solid rock. Okay, and then over here, what could we have that would have a low porosity, so it doesn't hold a lot of water, but it would allow water to flow through it, and that might be fractured rock. So rock that has been fractured, and it's got fault lines in it, and so the water could follow those cracks through that material. So this chart here, if you want to pause the video so that you can read through that, shows different kinds of materials, and it shows what their porosities are as a percent, and then it also tells whether or not it's a very permeable or not. Okay, let's take a break. When we come back, we are going to talk about what aquifers are.